Hello, Dr. Sanders. This is Benjamin Brodwolf, and I will be explaining assignment 9. So first I will demo the final product here. So we open terrain editor.java, and it opens a window that displays our terrain, our fractal terrain. And then we are going to use the left click to go ahead and lower the terrain, or higher the terrain, and our right click to lower the terrain. So whatever changes we make here, if we make 2 really tall pillars, you can see, those changes will be reflected if we push S and save the file. And we can also use F, by the way, to flatten the terrain, changing the Y coordinate to 0. And then, then what we're going to do is, after we save, we're going to we don't have to close. We can just go to carsimulation.java to prove that the new terrain is correctly operating. Once that opens up, we can drive our wheels around, and we can see that we have some pillars that have just appeared nowhere. 2 of them, in fact. And something very weird happens whenever we go up the pillar. That happens. This is the portion that I will be explaining for the assignment. So float sum x equals 0, sum y equals 0, and z are the vertices that we're going to be setting up to add all of the coordinates of the terrain's vertices. So x for the x coordinates, y for the y, and z for the z. They're all at 0 because we haven't added anything together yet. So for this for loop, we are going to, here I'll highlight it. This is going to start a loop that goes through every vertex in the vertices list. So each vertex is going to be in an array of 3 floats, basically, and each vertex index is going to relate to x, y, and z. And so sum x plus that is going to add the x coordinate for the current vertex to sum x. So, and the same for the next 2. So this is going to keep going for every vertex in the array of vertices. So then next, center x equals sum x here. We have, this is calculating the average x coordinate, and that's going to be doing that by dividing the total sum x by the number of vertices total, which is going to be using the operator there, dot size, to get that number for each one of the x, y, and z, so the different types of vertices. So then this start of another loop starts right here, and that is going to be changing their positions this time based on what the center that we just calculated. So now we're going to be subtracting center x from the x, y, and z coordinate, so that we can basically shift the vertex either left, right, towards, or using the y value toward the origin point, basically. So in this code here, we are gonna now set center X to 0 because after the shift of the origin point, the terrain is going to the new center is going to have the value 0. So this is going to make the terrain objects record to be now set to 0 for later use in our calculations. Okay, so for this section, we have a public void raised terrain method that is going to pass in those variables to raise terrain height around the coordinates xz. So the radius is going to set the size of the affected area, and then we have the amount, which is going to tell it how much to lift it. Then it calls modified terrain, which is going to do the work, and it's going to pass the parameters in as is, basically. And then for this lower terrain section, we're going to have this function to dig down into the terrain, basically, whenever we use the right-click button. And in this lower terrain function, it's going to use the same radius for the area size, but it's going to flip the amount to, now it's going to flip the amount to a negative, so it's going to lower the terrain. So basically 0.1 to negative 0.1, it's going to drop the y coordinate, and it's going to rely on modified terrain to actually do the actual work in changing. So then the flatten is going to use the target height variable to switch the origin point and the surrounding area to that place, and it's going to loop through the vertex list, and it's going to flatten those coordinates after checking the position, and it's going to also use the distance formula to basically see if the vertex is within like the origin point or the radius of the origin point, and then it's going to make it flat there using target height.